Good day, fellow. Seto is back. As for today, we are going to do the concept of force. What do we mean by the term force? Or what does the term force implies to you? It simply implies push or pull. You see? Then the very same concept of force can be divided into two. We have contact force we also have non-contact force. You see? Then okay, now what are contact forces? Can you give any example of the contact force? Let me assist you. Contact forces are those force, or let me just say force, exist when objects are in contact with one another. You see? Then as for non-contact force, the force exists when objects when objects are not in contact. You see, in simple terms, this side for non-contact, we don't need objects to be in contact, but forces, they will be there. You see, but that's for contact force, they have to be in contact always. You see, then what are those examples now? We have a normal force. We have a normal force. We also have what? Applied force. Tension, friction. You see? Then under non-contact force, example, we have gravitational force, magnetic force, and electrostatic force. You see? Now, let us consider a normal force. What is a normal force? Have you ever came across this term of normal force? See the term or the concept of normal force. Normal force is that force that is perpendicular to the surface. This force is always perpendicular to what? To the surface. You see? If I can even continue with the concept of normal force, I just want to explain the concept of weight. You see? Then I will come back to the concept of normal force. But bear in mind that the normal force is always what? Perpendicular to what? To the surface. You see? Then we also have what now? Weight. Weight. Weight is also a force. But which type now? A gravitational force. So it's a force that acts due to gravity. You see? Then now, how do we calculate weight? We calculate weight using this formula. W, I hope you can see, W is equals to mg. See? Where this m is mass, measured in kg, where this g is what now? Gravitational acceleration. Measured in meter per second squared. The value of gravitational acceleration is always 9.8. Then we include units meter per second squared. You see? We have a gravitational acceleration. G is always 9.8. Then okay, now let me then go back to the concept of normal force. Suppose if I have a flat surface, or let me write, yeah, I do have some space here. Let's say if I have a flat surface like this, let's say a box of mass, let's say if this object was 5 kg, and bear in mind, on a horizontal surface, just think for a moment, how many forces do we have in this scenario when this object is not moving, especially vertically? It's just standing or it's at rest. How many forces are we going to have in this case? We are going to have 2, which is now what? Weight. See? And also what? Normal force, which is perpendicular to the surface. You see the surface is like this, then the normal force is like this. We have Fn, normal force. This side we have what? Weight. You see? Then now, bear in mind that these 2 forces, they are not moving. We say they are at rest somehow. You see? Or somehow they are equally bent. They act in opposite direction, but they are equal. You see? You also have to note that when these 2 objects, they are not moving, somehow their net force, we say F net. Hopefully I'll have enough space. F net is equals to 0 because they are not moving. You see? As for the weight F net, it's more like adding all those forces that act on a body. On this diagram, let us consider everything that goes up to be positive, everything that goes down to be negative. Then we are going to have now F net, so the normal force, which goes up, and also minus weight, which goes down. You see? Then let us solve for normal force. Going to have a situation which is like this now. Weight. You see? Normal force now is equals to what? To weight. We know that weight, we can calculate it using this formula. Mg, you see? Then we can say mg normal force. Let us substitute our mass, which is 5, acceleration, which is 9.8. Then we are going to get 5 multiplied by 9.8, we get 49. Normal force, it's 49 Newton upward. See? Then now, I just want to know, how then are we going to figure out the normal force? If the situation now was like this, for the same box, if we had now a normal force with some applied force, let's say applied force of 10, force applied, let's say of 10 Newton, force applied of 10 Newton together with what? With weight. Let us try to figure out this one. Bear in mind that this box is on a horizontal surface. It is not moving along that vertical direction. You see, it's just standing there. You must know that your F net is going to be 0. You see? Then how many forces now do we have that goes up? 2 forces. We have Fn plus Fa. The only force that acts downward is weight, which is W. Then from here we can just substitute everything F into normal force. We do have applied force, which is 10. Our weight can just say W squared mg aside to avoid substituting mg every time. We have 5 9.8, 5 times 9.8, 5 times 9.8 is 49. Get 49. Substitute 49 here, equal to 0. Let us solve. 10 minus 49, we get minus, get minus 39, which is equal to 0. At the end of the day, we're going to get F net being 39 Newton. See? Don't forget that your weight was 49. Don't forget this value. Then now, lastly now, I just want to ask you again, how are you going to figure out your normal now? If let's say the situation was like this. We have a flat surface 5 kg, normal force Fn. Let's say now we apply an applied force downwards. We also have what? Weight now. Then I ask you to calculate what? The normal. The principle do apply. Say, okay, this object is at rest, then F net is going to be 0. How many forces? We have normal force minus now force applied minus your weight equals to 0. Then our normal force, sorry, our normal force is unknown. Then our force applied is minus 10. Lastly, our weight we said is 49 equals to 0. Let us solve. Going to have minus 10 minus 49. You get minus Fn being minus 59 equals to 0. At the end of the day, we are going to get 59 Newton for this problem. You see? Check. The diagram was the same, but we get different values. We get the different values. Why? Just ask yourself why. It's like now, when we applied a downward force on an object, as we apply a downward force on an object, what do we do in a way? We increase the forces that goes downwards. Eventually, because this object is not moving, its normal is going to be more or less compared to those values which are acting now downwards. You see? Check on this one. Then we had more weight acting downwards, being 49. Then this force applied which is going up, it reduces what? The value of what? Of a weight. Hence, it is much easier to slide a box when someone pulls it a little bit up. It's much easier to slide it. It feels lighter. You see? You can also see by the value of what? Of normal force. You see? Then this one is in between. But I wanted to explain this too. And also, it's much harder to push a box when someone applies a downward force on that box. Now, let us try to figure out this type of a problem. Let me just erase quickly. Okay, I won't take long. Okay, thank you. What would you do now if, let's say, I give you a diagram which is like this? Let's say we have weight somewhere there. The same object of 5 kg. Then I apply, let's say I apply a force to this object. Let's say a force of, let's say the force of 10 Newton at an angle of 40 degrees. Then I ask you now to calculate what? The normal force applied. How are you going to figure out this problem? As for this type of a problem, for us it is clear in this case that we are going to figure out two components. Actually, we need y component for this problem, not even x. But I'll also show you on how to determine the x component. You see, it's like now we have a diagram which is like this. If I were to redraw it again, we have a situation now which is like this. Our weight of force applied, then our normal, let me say Fn. I hope I drew it nicely there. You see something like this. We call this thing a free body diagram. But now we must resolve force applied in order to get what? The value of Fx and the value of Fy. We need this one, but I'll also show you on how to find this one. We have 10 Newton here. It's like now we have 10 Newton. Then we don't know the value of Fx, we don't know the value of Fy. For us to find the value of Fy, we are going to use sine. Why sine? Because this side is opposite to this angle. Or normally I just say saw or scissor like this. We're going to use sine for this side and cos for this side. Let's go and do those. Then we're going to say Fy, our hypotenuse is 10. Then 10 sine 40 degrees. 10 sine bracket 40. I get 6 comma 43 Newton Fy. For Fx is 10 cos 40 degrees. We are going to get 10 cos of 40. I get 7,66 Newton. 7,66 Newton. Like this, these two values. It's like now at this point I have a diagram which is like this. Hope you can see our Fx. This is our Fx. Then we have normal force. This side also have what? Fy. And we have what? Weight. But for us to determine the value of normal force, we are not going to use Fx. We don't need it. We are going to focus on our vertical forces. Which are these three? 1, 2, 3. Not this one. This one is horizontal. You see? By saying now, vertically, this object is not moving. Eventually, F net is going to be 0. Then we say forces that act upward, we have normal, we have plus Fy, we have minus weight equals to 0. Then normal, we don't have it yet. Then Fy, we got plus 6,43. Do you still remember what was our answer for weight last time? For weight, do you still remember that value? Because we're still using 5 kg. We said it's 49. Don't forget it, because we're still using 5 kg. Then let us calculate 4, it's 6,43 minus 49. Get negative Fn minus 42,57 equals to 0. At the end of the day, for Fn, I'm going to get for positive, because I take it to the other side, which is going to be 42,57 Newton. See, this is the value that we get for this problem. I hope you do follow. Then now, I thank you. You must know on how to calculate a normal force in various situations. And lastly, if you are new to this channel, kindly subscribe and hit that bell so that each and every time when I upload, you'll be able to see new videos. I thank you and enjoy.